All right, good evening, Warriors. I hope you're all well. And now it's time to get rocking with our last session together. Big tears of joy, sorrow, a little bit of both. Anyway, nice little quote from Rowdy Roddy Piper from the movie They Live, which was a long time ago in the 80s, but a great film if you get a chance to see it. I've come here to chew bubblegum and kick ass, and I'm all out of bubblegum. So with that, we'll begin tonight. That's not when our final, actually it is. Our final is on Tuesday from 5 to 7:30 p.m. Just been a long day. I'm going to snap out of it and finish strong. Here's where we're at on our map check. Tonight, we're going to go through Joker's Wild. Before that, I have a few admin comments I'll go through as quickly as I can so we can get into the meat of the matter. Tomorrow, I'll have your classroom interaction and participation assessments posted. And if you still want to get a piece of the reading day action, I have some time available. We'll talk about that in a second. Final exam Tuesday again, 5 from 7:30 p.m. All right, reading day reps. Everything that's not in gray, I have open. So if you want some time, I have time. If you're looking at this and you're like, I still want time, but the white periods aren't working out for me or whatever, just let me know. Come up on the net, email me. We'll figure something out if you want one-on-one time. If you don't, that's cool too. It's all about what you need. Here's what we're going to do tonight. We're going to take a class photo here in a minute. Kind of bumming me out because we've only got 12 folks on the line, but hey, it is what it is. I'll talk about a couple admin things, and then we'll get into the heart of the matter. So if you're out there and you want to participate in the class photo, and you can.
Dr. Stratskin.
Yes.
Colin just texted me and said that you denied him access and now it won't let him join the meeting at all.
Yeah, because Colin was signed in on some name that wasn't his.
Okay.
So text him back and tell him to try to sign in again. Is he permanently banned?
He said that he couldn't get on at all now, so I don't know what.
Okay. Well, tell him just to try again, and I'll just cease work until he comes back in. All right. So we're going to go through these other things, and we can take class photo here in a minute. So we'll keep the party going. So first things first, I just feel the need to say this for like 10 seconds and actually a little bit more, but y'all are warriors. You're warriors before you came to this class. You're even more warriors now. Keep your spot in Valhalla. What am I talking about? Well, Valhalla is where all warriors go when they die. It's a grand place where they probably sit around and drink beer and probably have a fight club on the side, but they tell grand stories of the fight. You lose your spot in Valhalla if you go to the dark side. What does that mean? Well, this is an exam where you're expected to do your own work. It's open book, it's open note. That is true, but it's not open phone a friend. So it's not cool to either provide someone with your exam packet so they can submit it on your behalf or on their behalf, or to do vice versa. Hey, can you hook me up? Can you give me, I'll do this problem if you do that problem, and then whatever. If you're thinking about doing that, for whatever reason that you just feel behind or whatever the case is, just come talk to me, please. We have more options before you do that. But once you do that, if you make that choice, our options go from here to here. And I have the ability to pick up on if this happens. I'll just say that. So I really don't like even talking about it because I respect all of you. And so I just say, hey, keep your spot in Valhalla, operate like a warrior does, and we'll be good. one way or another will be good. Alexa, has he had any?
He said he was gonna try again, but I don't know what's.
Okay. All right. We'll keep going. All right. Another thing just came to my mind was fix the bugs. So I don't think I've had an issue with this group, but if you're operating on some kind of flaky Excel version, you might go to this link right here with this smiling kid who's probably about to Zoom bomb me or something. Who knows what he's doing? But he's probably smiling because he's a college warrior like you. He clicked on this link and he got a free suite with Microsoft 365. So not only did he get Excel for free, he got Word for free, he got all this other stuff for free. It's legit. I'm not making money. There's no Shatskin discount code or anything like that. I used it myself to use my stuff at home as an educator, but you have the same benefit. So I would just encourage you to get on there, get a standalone version of Excel so that your stuff is wired for this exam, so that we don't show up on Tuesday and all of a sudden there's, Murphy's Law, some kind of weird thing going on with your Excel. So just fix the bugs if you've got them. If not, let's rock and roll. Okay, now into a little bit of technical stuff. So I can't remember if it was this group, but some folks with the D3M assignment had difficulty identifying what variable is independent and what variable is dependent. And we know that this is important to do because if we don't figure out X and Y, which is that Y being dependent, X being independent, then when we grab values and try to put them into a slope equation or an intercept equation, we're going to be all jacked up in there. Okay. And we have to load the Y values in first. So here's 3 bullets. All of them are ways that can help you identify and pinpoint that independent variable, that X variable. Okay, so let's look at the first one. If the narrative tells you that variable A is independent, it's independent. Okay, so if there's some variable, um, whatever, ice cream sales, and that's variable A, and the narrative says variable ice cream sales are seen as independent in this setting, well, there's your key. Okay. Another thing, the second bullet is not the opposite, but it's the complement to bullet number 1. So if the narrative says something like the sales of drinks are dependent on ice cream sales, well, then that just told you that drinks in that context is a dependent variable and ice cream is the independent variable. Okay. So what I'm saying, what second bullet is saying is if you have one, if the narrative tells you one, i.e. tells you what the dependent variable is, then you probably have the other, or you can figure it out. And you might say, well, what if I have 4 variables? Well, if one variable is being compared to the other 3, that one is either dependent or independent. And then, you just kind of need to figure it out. The last bullet might help you do that in that situation. And that was a situation on the D3M assignment. If the question asks you, predict variable B based on variable A, well, then variable B is dependent on variable A. So on the D3M assignment, the final assignment, it was predict the amount of epiphany based on a 3D gaming situation, these other situations. So in that case, epiphany was the dependent variable and the others were the independent variables. Okay. So, these are 3 ways. One doesn't replace the other. You can all use these. You can use these all at the same time to kind of help you bracket in to figuring out what's dependent and what's independent. But of course, it is strategic in nature. If you don't identify that and feel comfortable with that, you just start throwing numbers into Excel. Excel's going to give you numbers back. They won't necessarily be correct. Okay. So you want to make sure that you can do that. Okay. Moving right along. All right. And then the other thing I talked about was how options, ways that you can use to depict the correct notation for confidence intervals and hypothesis tests. So to just jump forward, remember I talked about this notation here at the end of the screen. This is a potential null hypothesis. So we want to have the correct notation in terms of the population mean. We want to have that nice greater than or equal symbol. And of course, a number is a number. So how do you make that in Excel under exam conditions? Okay. Well, since I'm already here, I'm giving you 3 ways you can do that. Okay. So since I'm already on this slide, I'll just talk the 2 ways that are on this slide, and then I'll go back to the other one. And either way, either of the 3 is fine. I don't care. Pick your poison. So one way is to handwrite it, just like I did here. Okay. You can handwrite it. You can take a photo of that. You can embed it in your Excel, or you can just send me the photo of it, or you can handwrite the whole thing, whatever, as long as I can read it. Another way is you could spell it out. So you could be in Excel and spell it out. Okay. The population mean is greater than or equal to 0.45. This here in italics is the same thing of this right here. Okay. Some of you might say, look at this and go, man, that's a lot of typing to do. Well, it is. You don't have to do it that way. The other way is I have it in a screenshot here. This is kind of clunky to do. So I'm actually going to just show you on a spare tab in Excel. And if you're going to do it this way, and I think some of you already have, but if you're doing this for the first time, don't let the first time be during exam conditions. And again, I'm not trying to patronize or insult anybody, but I kind of don't wait till I'm on the battlefield to see if my shield is going to stop an arrow being shot at me. I don't wait till I'm on the battlefield to see if my weapon works for the first time. So if you're going to do this, you might want to play around with it prior to stepping on the battlefield. So here's how you do it. Here we are in Excel. I'm going to go up here to Insert, and I'm going to click on Insert. My menu is going to change. And I'm going to go all the way over here to Equation. And it looks like the P-pop symbol. It's kind of inviting us. Use me. Okay, so I'm going to click on that. And for me, I have to sometimes click a couple times. Now, this time it gave me that. So I'm just going to make this bigger so you can all see it. I have to go home, but I can come back. All right. So I'm going to go back. I'm here. And when I click that P-pop symbol, you see this menu comes up. And I can't make that any bigger for you on my screen. At least I'm not smart enough to do so. Maybe if I do something here, I can. Boomer. I got it. I get called that every day. And it went away. Come on, man. Okay. All right. So I have this, right? Now, if I'm looking for that greater than or equal to symbol, well, that's one of them. Of course, it's going to give it to me nice and small. I'm going to make it bigger. It keeps wanting to do that. So this is what I'm talking about. You want to play around with this before you're trying to do this. And actually is much easier than it's just being like a Basenji. It's just not cooperating a whole lot right now. So there we go. I don't need this. Goodbye. Have a nice life. Go away, I said. Okay. So I have this now. I can move it around. I can put it where I want to put it. I could also put it in a text block. I can insert it there. If you're looking for P-pop and the population mean, they're not far away. So you're going to look at this little menu here and say, I don't see them. All you got to do is hit the next page over, boom, and there they are hanging out next to each other right there. So there's our population mean and actually cooperated with us. And then our friend P-pop. So I don't care, pick your poison, what way you want to do it. This, what I just showed you, is actually easier once you practice with it a few times. But I don't, again, I don't care. My goal is to make this as accessible and easiest for you. And if that means you handwrite it out, then so be it. Okay. All right. So that takes us out of there for now. And here I explain this again. It's not very good, but you go to that insert, you go over here to that equation piece. This is the menu that's going to show up. Actually, this one is the menu that's going to show up first, and there's your greater than or equal to signs. And then if you hit that little tab over, you have P-pop and the population mean right there. So there's that. And I think that's the end of our kind of initial stuff. Any questions on anything that I've talked about so far?
Dr. Sashkin, there is a like an easy like getaway to do the greater than or equal sign that I found out. For the keyboard, I just do the greater than or equal sign, and then I just underlined it with the under the home tab. I did that. I did that way.
So like something like this, and then like that.
Yeah, that's what I did.
Works for me. If you want to grab these dudes, I don't think you can do that another way.
I also know that if you have a Mac and you hold down Option and then hit like the greater than or equal to that are on the greater than or less than that are on the keyboard, it'll give you it. And if you hold down Option and hit P, it'll give you the pi symbol.
Wow. Learn something new every day. That's awesome. Okay, so cool. There's a number of ways. I appreciate you guys adding that on. Okay, cool. Other questions or comments? Everybody ready to take a photo? Okay, if you want to participate in the photo, and this would be the time that if you can, you want to turn your camera on. Lauren, I really want to see that American flag in the background. I'm just saying, go Phi Sig. Come on, there's Travis. Hi, Travis. All right, Lauren, I know you. There she is. Okay. And Cameron, I know you don't have a cam, which is kind of ironic since you're anyway. Okay, I will give you a 1, 2, 3 kind of thing. All right, so 1, 2, 3. All right, we'll take one more just for the heck of it, just because. All right, 1, 2, 3. All right, super. Appreciate that. That'll be on the gram. I'll put that on Canvas as well later on, as soon as we get done here today. Okay, for our fun today, we're going to start with Wild World on the Joker's Wild. All right. And the reason we're going to start there is because if we have time, we'll come back to blinkers, but we did something that looks a lot like blinkers the other day. So I'm not going to start with blinkers. Like I said, if we have time, we'll get to that. But regardless, within 30 minutes of us being done today, I will have the solution posted. I already have it queued up, ready to go. I just got to toggle that on Canvas. So have confidence that if you get lost in the sauce tonight and you don't want to come up on the net and say, I'm lost in the sauce, then, just hang along for the ride, hold on, get what you can. and know that that solution is coming and you'll have it so that you can check your stuff. Okay. So let me back up a little bit to give everybody context in case you haven't looked at this. And if you haven't, that's fine. So we have Joker's Wild. And just a simple intro is that Batman suspects that Joker has poisoned a hairspray. The hairspray, the name of the hairspray is Wild. So you get that wild hair kind of. Yeah, I know. Anyway, you get that wild hair going on. And Batman thinks that Joker has poisoned Wild. And so he's trying to run around and collect, he's trying to move past his instinct. His instinct is pretty good, but being the scientist that he is, he's trying to move past the instinct to gather pieces of data so that he can get consensus and backing from the citizens of Gotham. Because he can't just run in there like Chicken Little and say, oh my God, the Joker's poisoned this stuff, because no one's really going to believe him. All right. So he's trying to complement his intuition with science, which sounds like a perfect D3M problem. And if you're interested in it, there's a little bit of backstory behind this problem. Ironically, or kind of weirdly, I did not write this after coronavirus. I actually wrote it for the Warriors last semester. And it was based on this article that my wife told me about and the original Batman movie. At least from 1989, not Adam West, but Michael Keaton, Jack Nicholson. Really great movie if you haven't seen it. Kind of campy, but still pretty good. It's like pizza. Batman's always good. So we're going to bypass blinkers. We're going to start here with Wild World. And on this part of the problem, Batman is concerned that it's not so much concerned, but he's kind of wondering that maybe less residents of Gotham like and use Wild than the national proportion of the population. Okay. So his thought is, if that is true, if less people use Wild here in Gotham than like in New York City or California, and Wild isn't as popular here, then maybe I've got more time to run around and find these shipments and stuff like that. So he's really trying to figure this out for the purpose of time and how much time he has to work with. Okay. So like it says, if this is true, then Batman might have more time to contain the poison spread throughout the city. And he knows from the Bat computer that Wild headquarters claims that 45% of global consumers prefer Wild over other brands. Okay. So let's start with question number 1, which is state the null and alternative hypotheses for Batman's examination. So, Nick, why don't you start us out? What would that look like?
So the null would be the proportion population is equal to 0.45, and the alternative is the proportion population does not equal 0.45.
Okay. Very good start. So Nick identified this correctly as a proportion population. Sounded very confident too there, Warrior. I mean,
Oh, well, now you're
seriously.
going to make, but now since you didn't write the equal sign, now it look like an idiot.
No. You know why he had confidence? Because that beard.
No, I need a shave. I need a haircut. That's why I'm
why
wearing
he
this
got
hat,
that
so you can't
beard
see my
going
hair.
on.
I look
Yeah.
ridiculous.
Anyway, okay. So Alexis, what do you think should be in here in the middle? Nick said equal to and not equal to. What do you think?
I want to say greater
Where do you
and
want
then
to say
less
greater?
than the null.
Would be
Or should it
this.
go down? Yes, and then less than equal to. Wait, did I get that right? I hope I didn't flip them. I want to say less than equal to for the bottom.
Unless
Like
it's the
that?
top. Yes.
Okay. What do you think, Chastity? You agree with this or you think something else?
Wait, I think it needs this.
I think they need to be switched around. Like, yeah, the bottom goes on the top.
Okay. So like this. Okay. So this is a good setup. All right. And the reason is because he's thinking less. Okay. So Batman isn't necessarily, I guess he is thinking it's less than that global population. So this is Batman's thought, but he knows that he first has to disprove that. Okay. And the way that he would disprove that is that he would put this as his null hypothesis. Now, the global consumers aren't necessarily saying that it's greater than 45, but if Batman wants to start out, he has to put that in there. So this is actually our correct setup. Okay, so that takes care of Q1. Use a level of significance 0.01 and the critical value method to examine Batman's hypothesis. And we have this little bit here from a survey of 100 Gotham residents. Batman finds that 76 prefer Wild over other brands. Now you notice here how we have this term in education. It sounds so important, scaffolding. So scaffolding is a process where you kind of ease people into stuff. I didn't scaffold you into this. I just said, hey, examine a hypothesis, and then immediately we go to the conclusion. So Lauren, how should we proceed from here?
Well, you should divide 76 by 100 to get the
Okay.
x. And then n would be 100. And the alpha would be 0.01.
Okay. So P is going to be 76 divided by 100, which is that. And then we have our alpha. Okay. So this is our sample P. And we need a sample P to correspond with big population, P-pop. Okay. Remember that good old back tattoo. If we're working with this, then we need to work with this, and then vice versa. Okay. So, Jenna, what's a next thing we should do?
You would find your formula.
Okay. Which formula?
Would that be the one where you do like the P minus P pop over, and then it's like the 1 minus P pop, something like that?
Like this?
And then over N, yeah, I think.
Okay. I like everything. I just kind of want to turn up the confidence there, but I know you got it. You're just messing with me. So this is some kind of test statistic. Matt, is this a Z-stat or a T-stat? Matt dropped off on us. How convenient. I'm just kidding. Carrie, what is this?
My mute's on. I forget. I don't have my equation sheet on me.
Okay. This is a test statistic. And Delaney, is this a Z-stat or a T-stat?
That's a Z-stat.
Okay. How do we know that? Remember, just because I ask you doesn't mean you're wrong. That's like a triple negative.
Oh, okay. Well, I'm thinking because the proportion sign is in our null and alternate hypothesis.
Exactly. Delaney is correct. So whenever we're rolling with proportion population and a hypothesis test, we can say we're always rolling with the z-stat. When we're rolling with p-pop, we're rolling with z-stat. Okay, so here's our test statistic like Jenna identified, and we're going to plop those numbers in there. Lauren brought us to P being 0.76, and we know that we have our P-pop is 0.45. And that 0.45 is going to go down here. 1 minus 0.45. And then, Nick, what's our N?
It's 100.
100.
It's just the sample, yeah, or the population.
It's our sample.
Yeah.
Right there. Okay, and we put that all in. The heck? Chicken laying down on the job. And the chicken tells us that that value is, are you kidding me? 6.23. Okay, let's hold that thought. We're doing a critical value method. So, Cameron, what's something that we need to do and set up in order to evaluate this test statistic?
I'm trying to think. So the critical value, you need like alpha, right? The 0.0025 or something? Or the point or the level of significance?
Well, if we're using the critical value method, what is the critical value? And where does it kind of come into play?
I'm at a loss at the moment.
Okay. So Connor, what do you think?
Would you get your critical value from the alpha? Would it be the 2.33
Roger that.
table?
And what are we going to do with that 2.33, Connor?
You're going to make it positive and negative after you draw the graph.
Okay, so let's just back up here a little bit. With the critical value method, and I'm not saying you have to, but you probably want to determine your rejection region and your non-rejection region. So somewhere in here is that population proportion, which is 0.45 P-pop. Okay. And we're going to have a rejection region over here. Rejection region. And the rest of this will be the do not reject region. Now, Travis, why didn't I draw a rejection region over here on the right tail?
Because we're only going to be rejecting the left side of the. We don't need to reject. We don't want to reject. We're trying to find out the rejection region. If it's, I think, greater than or equal to 0.45, right?
Yeah, we're on the right track. So check it out. The rejection region, so we know that this is a one-tailed test. Everybody see that? Okay. Whenever we have this going on, we know it's a one-tailed test. All right. If this was equal to and not equal to, then that would be a two-tailed. But in a one-tailed test, we're only going to have one rejection region. It's either going to be on the left side or the right side. And the rejection region, where it is defined by what our alternative hypothesis says in terms of what we're looking at. So the fact that P-pop is less than 0.45 says that we're going to be on the left tail. Okay. Now let's go back to Connor grabbing this 2.33 out of the air. And some of you might be saying, how did he do that? Well, Connor went to this table in his mind, probably because he memorized it. And he said, okay, am I dealing with a two-tailed test or a one-tailed test? I'm dealing with a one-tailed test. Am I dealing with an alpha of 0.1, 0.05, or 0.01? I'm dealing with an alpha of 0.01. And because we have a one-tailed test, he's only going to select one of the two values, positive or negative 2.33. Now, because we're on the left tail, get out of there. Okay, because we're on the left tail, that critical value is negative 2.33. Okay. Now, Matt, what do we do now? We have this T-stat of 6.23. We have this critical value of negative 233. What do we do now?
We have to determine whether or not it is we're going to reject or not reject it based on those two compared.
Okay. So if what we're really looking at is a decision rule, Matt is correct. And a decision rule is, I'm just going to write it up here. If our Z-stat, because we have a one-tailed test, it's a very simple decision rule. If our Z-stat is less than negative 2.33, we would reject. Okay. Otherwise, we would fail to reject. All right. So this kind of says if our value falls out here less than negative 2.33, then we would reject. So Alexa, do we reject or fail to reject in this case?
We would not reject the null.
Okay. So Alexa is correct. We would fail to reject because 6.23 is way the heck out here. Okay. So, questions so far? All right. So we would fail to reject. Everybody remember that. I'm going to get rid of all this stuff. All right. And I'm just going to write FTR up here. So we failed to reject, but what does that mean in the context of this problem? What does anybody think? Jenna, what do you think? We failed to reject, so what does that mean in the context of this problem? What does Batman have to do now? Or what does that mean to him?
So would that be saying that so is it less than 45% of the consumers prefer the brand over the other ones?
Remember his alternative hypothesis. That's what he thought it might be. He was curious. His was this. Okay. But when we failed to reject, the null was this. So we failed to reject
so
that.
then it
right
is
there.
greater than or equal to.
Okay. So what does that mean in the context of the problem?
That either 45% or more of the customers prefer the Wild over other brands.
Okay. So what does that mean?
I'm not sure.
Yeah, this is a tough one. So what it means is that he doesn't have that much time because more people in Gotham like Wild than the essentially the global population. Remember, he was hoping that less did, so he had more time to work with. And because he failed to reject, it actually means he has less time than he would like to contain the spread. Okay? So again, this is tough for anyone to really get into. And this is a particularly tough problem. So again, we're all penguins, we're all warriors, we're all warrior penguins, if there is such a thing. What I'm coaching you all to get into the mind of, okay, I have the math, but now what does it mean? And you just have to look back at the original problem. Okay, remember, if this is true, he may have more time to contain the poison spread. Well, it's not true. So he has less time. You got to hustle. You got to hustle more than he normally does. Okay, so moving on, I'm just going to clear some space for us, and let's attack this last one here. If Batman used his sample proportion to construct a 99% confidence interval for the population, actually, this should read proportion. I need to correct that, because he can't use a sample proportion to estimate a population mean. So that's my mistake. All right. So he's going to construct a confidence interval. What would his confidence interval be? So, Connor, how do we approach this problem here?
Not 100% sure
Okay.
what the first step would be.
All right, Travis, what do you think?
Well, wouldn't you set up, you do the null and alternative, but it would be, wait, we're doing the confidence interval. 1 second. I don't have the right notes out for that one.
Okay. Carrie, what do you think? Carrie, on mute.
Sorry.
That's all right.
You have to find that on the chart, right?
On what chart?
Oh gosh, one of the ones in the PowerPoint. I'm trying to find it on Canvas right now.
Okay. All right. Lauren, what do you think? You want to give a stab at this?
Would it be plus or minus 1.29?
Plus or minus 1.29.
From that, I don't know what that chart's called.
Okay, so let's back up. So we need a formula for confidence interval. Okay, and that formula for confidence interval for population proportion, all right, it's going to start, remember, when we're dealing with population proportion, we're going to use the sample proportion to estimate what that population proportion is. Just like it says, we're going to use the sample proportion to estimate the population proportion. Now that I fixed that. So our formula begins with sample P. Okay. Now, Alexis, what do we think is next in our formula? Just guess. Remember, on a population or a confidence interval, we have an upper limit and we have a lower limit. So what's going to follow next in my formula? What do you think, Alexis? I think you're on mute if you're talking. I don't know if Alexis can hear me, so I'm just going to keep going. There she is.
Sorry, I was looking for it because trying to find it. It's a confidence. Is it? Is it similar to the last equation we used? Oh, plus, never mind. Nope, never mind. It's not.
Yeah, sort of, but not really. It's kind of like Hardee's. It's hard and easy at the same time. You ever think about that? That's the first joke I ever told my wife. She didn't think it was funny then either. All right. All right, we're going to keep rolling. Here it is. This is how we're going to do confidence interval. I just need to get my pen back. We're going to start with sample P plus or minus our friend Z, square root of P times 1 minus P over our good friend N. Okay? Got to have those confidence interval formulas ready to go because we're doing a 99%. All right, we can go, and this is the Z because we're doing proportion. We can go to our old hack table. It's not the same one as I just brought up. It's another one to get that value of Z. Remember, when it's 99%, I'm going wide. I'm going way wide. My butterfly net is wide. I'm trying to catch 99% of values that straddle the mean. So my Z is going to be bigger. Okay, bigger than smaller. Okay, so anybody know what Z is? Connor, you know what that Z is going to be? For
Is it
99?
going to be the 2.58 or is it going to be the 2.33 again?
You should have stopped at 2.58. You had me at 2.58. That is going to be 2.58. All right. And P we've already got. That's that 0.76 that Lauren identified. Throw that bad boy in there. N is still going to be 100. That's that Nick identified. And then that 0.76 is this 0.76. Okay. We're not in the end zone. We're kind of close, but we're not there. All right. So we got to do these computations. And when we do that, we get this down here. Point 649898 greater than or equal to. And right here, smack dab in the middle, we have P-pop less than or equal to 0.8702. And that is our confidence interval. Now, let's just look at that. And in the description, the notes for this, or the solution, I talk about this a little bit. Remember we talked about, let me just clean up my stuff here. This looks kind of soupy. Remember we talked about Batman wanting, hoping really it was less, but then his hypothesis, he failed to reject. So he kind of wants to just take a guess at the magnitude. And this essentially says that based on his sample, the proportion of Gotham City residents who use hairspray, between 87% and about 65% of them. So 65 to 87%, somewhere in there is how many are using wild. That's a lot. And so Batman doesn't like spaz out. I mean, he's Batman, but he's like, dude, I got to move like super fast. Okay. But he's not going to call Superman. And in the notes, I talk about why he's not going to do that. But I won't get into that now. Any questions on what we just did? Okay. Let's go to quarantine. Again, kind of eerie that I wrote this before COVID. At least it is to me. All right, let's check it out. Batman believes that the poison within wild adversely affects people. Bottom line, by increasing their reaction time. So this gets a little confusing right off the bat. When I have an increased reaction time, it actually means that I'm reacting slower. So for example, if it takes me 9 seconds to react to something, but then I've been poisoned, it probably takes me 10 seconds or 11 seconds or 15 seconds. And the slower reaction time I have, or at least the worse my reaction time is, the more chaos can ensue, because a car might be coming at me, and before I might be able to get out of the way, but today I might get hit, that kind of thing. Or somebody might try to mug me, and before I was poisoned, I might be able to run away, but now I'm kind of sluggish and I might not be able to run away, so I might get attacked. So Batman wants to see if reaction times have become greater than 9.5 seconds. Okay, so once again, let's set up the null and the alternative hypothesis. Let's get rid of all of our stuff here. Okay, so Carrie, what might be our null and alternative hypothesis? We want to vector in on that statement right there. You're on mute.
Gosh, I keep doing that. Okay.
That's all right.
Would it be the mule is greater than or equal to 9.5?
And what are we putting over here?
Would that be P-pop?
You tell me.
Oh gosh. I'm not 100% confident on that.
Okay, that's all right. Travis, why don't you pick up where Carrie, why don't you pick up here? What do you think? What do we want to do with all this?
I think you're gonna use P-pop, and it's gonna be I guess is it less than 9.5?
Down here?
Yeah.
Okay. Matt, what do you think? Agree, disagree, alter? What do you think?
The numbers and signs are right, but it's mu
Why is it mu?
because we're looking at average reaction times.
Okay. Matt is correct. So we're looking at average reaction times. It's not a proportion of anything. It's a reaction time. So now this right here, if Batman wants to see if they've become greater, all right, then we need to switch these around. Okay, because his null would actually be that they're less than or equal to. Because if he wants to see if they've become greater, essentially that's his hypothesis, that they've become greater, that the poison has made reaction times greater than 9.5 seconds. Okay, so if he thinks that, then he's first got to disprove the opposite, which would be the status quo. Okay, so he's got to disprove himself in a way. All right, so this is our correct setup for this. Okay. Conceptual question, Q2. Batman wants to be very sure of his hypothesis test, and here's why. Gotham City has a distribution center of wild. Okay, so picture this. And I don't know if you've ever been to the distribution centers for Amazon, but there's like 4 of them in Carlisle where I used to, I didn't live in Carlisle, but I worked there. So imagine a distribution center full of these wild hairspray bottles. And he wants to quarantine that place. He wants to shut it down, lock everybody in so that the poison doesn't get out. But he doesn't want to be like the boy who cried wolf or like Chicken Little and run in there and be wrong. So he wants to be very, very sure that he's not wrong. So with that, Cameron, what kind of significance levels should he use? Would he use 0.1? Would he use 0.05? Or would he use 0.01? What do you
It would
think?
be 0.01 to be more accurate, correct?
Yes. So to be the most sure that he's not wrong, he would use the lowest significance level possible. Okay. So he's going to go ahead and do that. He's going to use 0.01 as his alpha. And he's going to use the p-value method to examine this hypothesis. So he's got this set up right here. He's got his alpha. I forgot to mention he's got some sample stuff over here. He goes ahead and he gets a sample of 35 residents who've used Wild. He measures their reaction times on his BAT stopwatch, and he takes the average, which is 9.95. And then he has a standard deviation for that average or that sample, which is 1.2 seconds. Okay. Delaney, what do we need to do now?
Okay, there we go. So then we're going to use the would it be the equation we used in the last problem, or would it, I guess it's a different one.
Would be a different one because this is different. And there's another reason that we have differences. So, Chastity, what do you think? What should we do now?
I think it's the, sorry, I'm trying to, the x bar minus m over the standard deviation over root n.
Okay. And which standard deviation? What's our symbol here?
Oh, the sigma or whatever.
Okay. So, Lauren, what do you think? Do we put our sigma here or do we put something else?
I think it's sigma 2.
Of course you do. Alexis, what do you think?
Put S
Why do you think we put S?
because it's standard. Because that's what the standard deviation is. Because we have it.
So the S that we have, the standard deviation that we have is the sample standard deviation. If we look up here, we do not have a population standard deviation. And remember, the sigma is our population standard deviation. So when we're dealing with mu and population mean hypothesis testing, the second question, or a very critical question that should come up early, is do we have this or not? Okay, so if the answer is no, we have to use S down here. Okay, and as we shake this problem, we don't have a population standard deviation. Okay, so we've got to put S down here. And just to put that icing on the cake, this is the T-stat formula, which also tells us we're going to be working with the T distribution. All right, so let's put our numbers in here. Our X bar is 9.95. And our mu is that 9.5. Our sample standard deviation is 1.2. That's it right there. And our sample size is 35. And we put this in here. And Chicken says 2.21. That is our T-stat. Okay. So, Nick, what do we do now with that 2.21? Remember, we're rolling with the p-value method. Go ahead.
Oh, no, I'm going to say that wrong. No, I was going to, never mind. Don't you have to do something with the DF now to find the T? Oh, I'm trying to look. No, that's wrong too.
No,
Oh,
we're going to need to know degrees of freedom. So let's roll with that. So what are our degrees of freedom? Just mathematically, what is our degree of freedom in this case? How do we figure that out, what it is?
I don't remember. Oh
Okay.
my gosh. It's something minus and sorry.
Okay. So degrees of freedom is n minus 1.
Oh, gotcha. Okay.
So
it's
we know
35.
35. Yep.
Yeah.
So our degrees of freedom is going to be 34.
Yeah.
Okay.
So then you got to use that to find the T, right?
Well, I have my T stat. Really what I need is my P value. So let's see here. Who haven't we talked to lately?
Oh, I get it. Okay.
Jenna, what do you think? How do I find my P value given a T stat of 2.21? And, well, just what do you think?
I'm not positive.
Okay. You have any guess?
I was gonna say when I did those ones on Pearson, I kept getting them wrong, so I just used like a calculator I found online. So I'm not positive.
Okay. Alexa, what do you think?
Can you repeat the question? I'm sorry.
Yep. So we've got this T stat 2.21. And the next thing we need to do is find the P value.
Okay.
So how do we do that?
You would you use the formula for Excel, like where you type in the T-dist?
Mm-hmm.
So I used the T-dist RT.
Okay.
No. Yes.
Why did you use RT?
Because we're finding the right tail
Yep. And how did you know that?
from the alternative hypothesis.
Yep.
And then,
yep. Keep going.
and I plugged in the 2.22 for the T-stat value, and then I plugged in the 34 from the degrees of freedom.
Okay. That is correct. Everybody see that? Okay. So 2.22, 2.21, that part doesn't matter. And then Excel is going to prompt you for degrees of freedom. Remember, when you type this in, and Alexa is correct, we're doing a right tail because of where this symbol is in the alternative hypothesis. It is in the right tail. You may look at it and say, well, it's on the left, but the greater than means it's on the right tail. Okay. And when you type this in, it's going to prompt you for X. Remember that X really means it wants the T stat. Then you're going to put degrees of freedom in there. And that returns a P value of 0.06. I'm sorry. It's not 0.6. It's 0.166. Okay. And that 0, that's a P value. And so we're going to compare that P value, 0.0166, against the level of significance, 0.01. All right. So we compare this versus that. And Travis, what do you think? Do we reject or fail to reject, and why?
You would you fail to reject because p-val is bigger than what's it called? It's alpha.
Yes, that is correct.
I think of the name.
Travis is correct. So alphas are either way you want to roll with it. If the P value is lower than the level of significance, then we would reject the null. Well, it's not. It's greater than, like Travis said. Or we could say that the alpha is the fish. And so if the alligator eats the fish, we reject the null. Alligator's not eating the fish. It's eating this value right here. Okay. So we would reject the null hypothesis. And in the context of this problem, really, Batman wanted to get some credibility behind thinking that reaction times have increased so that he could quarantine the distribution center. Okay, but because he has failed to reject his null hypothesis, he really can't do that. He can't go into, you know, the local township or whoever who controls the distribution center and say, hey, here's the results of my hypothesis test, because he failed to reject the null. So again, even though he instinctually knows that these bottles are poisoned, he does not have sufficient evidence to reject his null hypothesis. So he just got to keep working other methods to contain the poison of wild. Okay? Questions on anything we did? I didn't mean to zip that away. Questions on anything here? Okay. We're kind of in this weird spot where we have about 8 minutes left, and we probably need longer than that to work any other parts of the problems here.
Wait, I
So,
did have a question on that one. So how do you notice that you use that, since it says standard deviation, that you use S instead of sigma? Could you go over that again?
yes, I can. Let's see here. I moved my stuff. So before I bring all that, let me just write anew. And so we don't have all that clutter. Okay, so when I read this, I got all this, got the context. Batman wants to see if reaction times have become greater than 0.95. All right. And then this here is all this info is coming from his sample. Okay. And sample info is not population info. So out of this, we've got X bar, that's the sample average or sample mean, is 9.95. Okay. And the respective standard deviation. When this word respective means the standard deviation that goes with his sample. And that sample standard deviation of the sample is S, and that's 1.2. So by the time I get to the end of this green box, I still don't have anything that would tell me anything about the population. I definitely don't have a sigma. Okay? Does that make sense?
Yeah, that makes more sense.
Now, Lauren, if somewhere in here, maybe, you know, there was, you know, Dr. Rowland is a world-renowned expert on reaction times and thinks the population standard deviation is 2 seconds, then that would probably be sigma. But we don't have anything like that. You see what I mean? So if you have something like this where it's just there's nothing in here, and it makes sense because this is new territory. I mean, he's strictly going off a sample. Okay. But these are good questions because that when you're dealing, you know, the first thing is, what am I looking at? When we do our null hypothesis and everything, we identify like Matt did, we're dealing with a population mean. Well, once we make that decision, this is our next question. Do we have sigma? So it should be, I want you to get to the point in the next couple days, earlier than later, where it becomes mental muscle memory. Okay, population mean, do I have sigma or not? Shake, shake, shake. I don't, so I'm going to roll with T. I do, so I'm going to roll with Z. All right, so just, and through repetition, any of us will get to that. Excuse me. All right. Okay, other questions on this one? Questions on anything we've done tonight? I have my last closing thing, but it's hiding from me. Oh, there it is. All right. So I just want to say a few things before we part ways as a group for the last time. Kind of makes me sad. I've enjoyed my time with you all. I sincerely have. You should consider yourself a bad mother. Now you got these mad skills. All right. And you shouldn't be afraid to use them. You should feel empowered. Now you can complement intuition with science and take down all those posers that are like hovering around your doorstep, pontificating with their Starbucks in their hand. And you can say, really? Why do you say always? Why do you say never? What's the standard deviation? Does this follow a normal distribution? And with that tiny little bit of science, you will bring people to their knees, and you very well should, because you should take no BS. Now that you have this knowledge, you almost have a moral responsibility to stop people who are saying incorrect things. And I'm not trying to sound like a conspiracy theorist, but these people are a lot more prominent than you might suspect. All right. So when you see something on the internet, you see something on Facebook, I know Facebook's kind of a boomer thing, or on the gram or wherever, or just someone's talking, and it doesn't make sense to you in the context of the knowledge that you now have, you should shut them down. Or at least challenge them and say, where did you get that data? How did you do that analysis? What all was involved in that? And you would be surprised how many people go running for the hills. Just as importantly, you all did the Way of the Warrior project. I enjoyed all of them. And it is so important, not just within this class, but within education and life itself. Life itself is all about this quote. I go back to this like every third day. Absorb what is useful, discard what is useless, and add what is specifically your own. You're going to move onward past the exam, past this course, but you're still going to have this knowledge. You're going to forget some of it. You're going to want to forget some of it, but there's going to remain that part that sticks with you, and keep adding to that. I think many of you, if not all of you, now have the ability, you go, man, D3M is everywhere. You are right. And because that is true, you should not hesitate to use these skills that you have accumulated. Now, many of you, or some of you, or maybe just a few of you, came to this course kicking and screaming. I don't want to do math. I don't like this. And maybe you're still kicking and screaming. I still don't like it. But hopefully we've dissipated some of those feelings. And maybe you've changed a little bit of your mindset about how you feel about this. Because in the past, you might have felt, I was scared. I don't want to do this. I think I'm going to fail. And you all have such great power and ability. So don't be scared. Take that fear. The only fear we have is fear itself. Embrace the fear, like Batman in a cave. and pet the bunny. I mean, it's not that bad. What's the worst thing that can happen? The bunny will bite you. But D3M is not something to be scared of. It's quite the opposite. And you all have no reason to be scared. You have no reason to be scared within the next week for the final. And you certainly have no reason to be scared in life with this material. And so I would just encourage you to get past the fear, turn that fear into energy, put that energy into the gas tank, and proceed with the war on knowledge. And knowledge and strength is built through repetition. So in this next week, keep repping. Get more reps. Don't get junk reps. Don't just do reps for the sake of reps. Do quality reps. With every rep, embrace the repetition. Did it go well? Did it not go well? If it didn't go well, it's even more important to understand why. Why didn't I get the right answer? What is going on? And embrace that repetition. Strength is built in D3M through repetition. Now, let's talk about the short term. I know you're going, hey, all this motivation stuff is great. That's awesome. But can you take my finals for me? Because I'm looking at like 4 and I'm stressed out and I'm nervous about them and I empathize. You all can do it. Believe in yourself. Stay in the fight. All right. Don't let those walls close in on you. Remember that you are a warrior and you will rock out this next week. You all have it in you. And I look forward to your success. And on that note, do not hesitate to let me know how I can help within the next week and beyond the next week. And I know what you're thinking. You're thinking, well, you can help me by not having a final. How's that? Well, that's not what I'm talking about. Okay. But beyond that, if there's a way I can help you, either both in the next week, beyond next week, I look forward to that. You know how to get hold of me, send up the signal, and let's keep moving because you are the future. This world is in crisis. I don't mean to sound alarmist, but these times are not standard times. This is not business as usual. And we are counting on you to lead us through these times because they are going to go on. Pretty soon, I'm not going to be able to spell my last name or recite my social security number. I'm not letting myself off the hook, but you all have the intellect, the creativity, and all that. And now you have these mad skills to take us where we need to go. We are counting on you. And the way to do that is through knowledge and those mad skills. So I am looking forward to continually celebrating your success. Let me know how I can help you. And with that, I wish you the best. I'll stay on the call until we clear. Otherwise, I'll see you on the street. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.